Hello, everybody. Welcome to our webinar series. Today, we have a very interesting topic, again, on the QRNG side of life. And we are covering the topic, which is called how to secure the IoT space going forward. We have two very well-known speakers in our company and also outside. I would like to welcome Tom Stengel from the US. Hello, Tom.
Hello, thank you.
And Bruno Hüttner, today from Geneva.
Hello.
Welcome, Bruno. So first, before we go into the session, some informations. You have always the chance to ask questions in the chat area, right? So we will try to answer as best as possible on the end of the session. There will be a Q&A session as well. There will be also two polls on the end of the session where you can give feedback and your judgment on several topics. And I hope you enjoy the session right now. Keep in mind, it's about IoT security, so stay secure and safe. Tom, it's on your hand. Go forward.
Okay, thank you very much, and welcome everybody. And let's switch over to a slides-only mode here. And thank you very much. We're going to talk about IoT security and the value we bring to IoT security. We're going to give you a little bit of information as well on the quantum technology that is providing this increase of security, as well as how easy it is to use in your design. And the first thing is the quantum decade, it's real, it's now. This is the quantum decade. It's not science fiction. It's not 10 years from now or 3 years from now or next year. It's already happening now. In fact, there's already people walking around with quantum technology in their pockets. You know, I can talk about the fact that ID Quantique has been delivering quantum technology products to various industries for 19 years now. But this year, the year 2020, is the first time the quantum technologies ended up in a consumer product that people put into their pockets and carry around. We're very proud to be called out by Samsung, where they put secured by Swiss Quantum. We are a Swiss company. We're very proud to be in the Samsung Galaxy A quantum phone. We're also very proud to be in the VinSmart Aeris family of phones. And they also call out the Quantis QRNG. Quantis is our product name, our marketing name for the phones, for the chips that we use in the phones, but also for all of our QRNG product family. You know, you're going to hear a lot, and you're probably already hearing a lot about quantum technology, and a lot of it is around quantum computing. You know, interesting announcements by NASA and Google and IBM and various governments around the world in every hemisphere. And it is appropriate that quantum computing gets a lot of press. It's going to do a great amount of things for the human race in the future. And there are other uses for quantum technology, and today we're going to focus on quantum security. So everything that ID Quantique is doing is involved with supplying quantum security to you with the QRNG chip. So ID Quantique has been doing this for a long time, and 19 years ago, in the upper left-hand corner, we made the first product that ID Quantique made, which was a quantum random number generator. Of course, it was about 1/2 meter wide and quite physically large. And, you know, over time, not only did ID Quantique come up with other new products based on quantum technology, but for the quantum random number generator, we shrank it to a board size, and then we shrank it to USB, and now we've shrunk it into a semiconductor chip, upper right-hand side. It's actually a family of chips, the smallest of which is 2.5 millimeters squared and less than 1 millimeter thick. And that, of course, is the one that's in cell phones and Internet of Things devices. This is something that we have been doing for 19 years and continue to drive into the future for higher performance, lower cost, and lower power consumption. You know, in 19 years, we've already have quantum technology-based products making quantum enhanced encryption in a lot of different markets. Of course, quite a bit of it is in data centers and in telecommunications backhaul. It's only this year that we achieved the amount of shrinkage and power reduction to work in mobile phones and Internet of Things sensors and edge devices. And, you know, going forward, you know, why would you want to do quantum random number generator? Why is there a need for explosion? Well, it's largely about improving life and convenience and ease. You know, it looks almost silly to think that at some day in the near future, there'll be a trash can that's wired. But the fact is, there already is a trash can that's wired in the world. And it seems kind of silly to think of a lot of things. You know, my door in my house, about 3 years ago, I went full electronic, and I haven't used a mechanical key in a long time. It does mean it's an attack point for a hacker. You know, if a hacker can take over the electronic lock on my door, not only can he use it to open the door and come in, he can actually use it to track when I leave the house, so the house is empty, if he can hack the phone and get into it. And you know, virtually everything in our life will be this way. Today, there's more than 20 billion Internet of Things devices that are wired one way or another. And within 5 years, that's forecast to be 43 billion units. And the reason for it is very simple. All of these things provide more convenience and ease, better access to healthcare, better access to easy implementation of safety, and all these things are hackable if you do not take time to secure them. And all these things can be ransomware. You know, it's funny, the picture even has a broom here, and I'm trying to figure out whether that's a regular broom or a Quidditch broom, but in the end, eventually someone's going to come up with a neat idea and wire the broom, and the broom will have some reason why it makes sense to be wired. So really, the principles behind it, supplying security to Internet of Things, these are just establishing an industry. They're not ID Quantique principles, but everyone pretty much follows the same basic principles of authentication and control and establishing root of trust and secure management. Very important, the encryption of data and key management, and of course, managing and monitoring your crypto agility. These processes, each part of the 5 principles actually has a requirement for secure encryption built in. So, you know, if you look at the chain of trust, the stack of trust, if you will, from the person who's at the top here down and through out into the cloud, each level has a different need and requirement for security as you establish trust and making sure there's strong authentication. And one of the fundamental keys is not just to encrypt the data, but to encrypt the data as close as possible to where it's created. Because if you encrypt it where it's created, you remove possible entry points for a hacker to get a hold of the data before it's been encrypted and do something bad with it. So in the end, the security is weaved throughout the whole IoT stack. So in that world of more than 20 billion devices today that are in your home, in your pocket, in your car, in your office, certainly everywhere in public and growing, and they're all connected through the cloud to large data banks around the world, each one different municipalities versus say hospitals versus private institutions that are securing your data. And all of them are using algorithms to secure those data and to secure the communications channels. And that's why you need the highest level of encryption. And this is where we come down to where is the money? And the start here, we're really at the beginning of Internet of Things traffic in the world. The amount of devices that's going to be added in the next 5 years is staggering. And right now, 98% of that traffic is unencrypted. And it turns out, when you talk to the consumer about all the things they want, and some of them want things to be cheaper and some of them want more features, but the number one thing that they all want is security. The number one thing that they're concerned about is security. And there's a direct link between that concern and driving the revenue of any product that you make in the Internet of Things by adding security. 92% of companies report an increase of sales or an increase of product usage after a device has been made more secure. And I should say provably more secure. As an example, implementing quantum enhanced security more secure. So there's a direct correlation between increasing the security level and driving up your business with your Internet of Things products. So some examples to go through here, and this is one example. This is some pretty straightforward video encryption. In fact, this one is one of our partners, KCS, and they're using that video encryption for things that stream video, you know, drones and video over internet phones. They're actually using it for some other subtle uses as well, as they implement things like automatic meter reading, and where there's some benefits that they can add with this product in terms of making it so they can provide better service to the end customer. And each of these things is driving more customers to them when they implement quantum enhanced security. There's a new level of video security that has to be implemented to keep people from seeing the video or seeing whatever the communication channel is that are not authorized to see it. An important part of that is making sure with ID Quantique, we made sure that the way you implement the QRNG into your existing designs does so without compromising in any way the speed and the quality of what you're transmitting already. And we're gonna get into the implementation in just a little while. So here's another use case, in very specifically, it's still video, but it's video surveillance cameras. And in the early days of making IP cameras, they did not have encryption at all. The video would just stream through a connection, and you know, there's lots of stuff written about how easy it was to pick off and get copies of unauthorized video. Now, of course, they make more and more cameras with encryption built in, but a lot of those are built with one key. During the manufacture of the camera, they assign one key to that camera, and for the life of the camera, it has one key that it uses for, to unlock any video that's been encrypted by that camera. And that in itself is a weakness, because over time, if somebody finds a way to get the key, it's permanent. And so the state of the art for security is to continually update the keys and to not rely on a key for the life of a product. In fact, there are some municipalities now, governments and various municipalities, who are now requiring IP cameras that not only do encryption, but have frequently updating keys for the highest level of security. So it's another use case where being able to implement quantum enhanced security, because quantum enhanced security is all about making the best possible key, which we're going to show you in the technology section in a minute. In addition, we have the Internet of Medical Things, a growing term to highlight healthcare related information and data and separate challenges with monitoring that. You know, at your doctor's office or in the hospital environment, it's been common now for years to have these roll around carts, which can have anything from very complex measurement equipment and testing equipment to simple blood pressure machines, but they all have the screen with the magic connection, which with a few taps of a button opens up your healthcare when the doctor is standing next to you or standing in front of you. And that information is in itself very important, and you don't want people to know your medical information. But most doctors' offices attach your medical information to other critical information about you. And I don't just mean your address, that's important, your spouse, but also your government ID number, your social security number, whatever it's called from whatever country you live in. You know, very often that's all contained in the same file. So it's not just that somebody can lift your health information, somebody can lift your entire identity out of many of these health databases. Now that's pretty important to secure with the highest level of security, particularly with quantum enhanced security. And now there's the new rise from an Internet of Things point of view of home medical devices, particularly with the pandemic going on. There's a trend going on of people doing basic, you know, things, basic doctor appointments like an annual physical or things that don't require extensive testing. So for less than $25, you can buy a blood oxygen measurement device that also do your heartbeat. You can get, for less than $20, you can get blood pressure machines. You can get all kinds of medical devices. In fact, for less than $99, you can get an EKG now. And they're all wired. Most of them work through your cell phone or your laptop. And this is very convenient, especially during the pandemic. If you are going for a routine doctor's appointment, you don't need to do anything other than have a video conference with your doctor while you hook up with this equipment, which costs less than $100 unless you include the EKG, and then it's less than $200. And all of these things are, again, tiled right in with your doctor's office. It's wonderful. It is an amazing way to avoid the pandemic for basic medical visits. And at the same time, it's all hackable if you don't implement the highest level of security. And this is where we're getting in with the quantum enhanced security. We'll show you how to implement that in an Internet of Things device in a couple of slides here. And then there's the point of sales equipment. And for decades now, you take out your credit card and you use it with a point of sale machine. And for a long time, the big concern was if somebody got the credit card number and they could charge something, and then the credit card company job to make sure that if it's a big charge, you don't get it. They have their fraud departments, et cetera, et cetera. But now there's a bigger problem, which is the credit card companies, they also have your government ID or your social security number. They also have all of the information somebody needs to steal your ID, perhaps more valuable than the $500 that somebody might steal in one transaction with your credit card, or $1,000 they might steal. Perhaps even more valuable is if they can use that information to get all of your data and steal your identity. That's a huge thing. That's big money for them and a huge problem for you. Much bigger problem than the simpler thing that most of us experience at least once in our life, where somebody stole a credit card number and someone charged something for $299 and the card company had to take care of it. Now we're talking about losing all of your personal data as part of that and having somebody steal your identity. This quantum enhanced security is a simple and inexpensive way to upgrade to the best security keys in order to protect the point of sale equipment. And the best part is the user gets all the benefit of quantum enhanced security, and there's no hassle for them. They're using it without even knowing it. You should certainly market it and let them know it, but there's nothing they need to do other than what they've been doing all along. And the only part is you have to implement is fairly easy to do. And then we get into home appliances, and this is I was mentioning before about my front door lock has been electronic for years. My heating and home heating system has been controlled electronically for years. Very convenient. It automatically turns down at night and turns up during the day, or if we're out of the house for a long period of time, it turns down. So it's energy efficient, it's green, it's smart, it's hackable, and it needs it's an Internet of Things device that needs the highest level of security in order to make sure that somebody doesn't take it over on me and maybe turn off the heat on my house in the middle of the winter. All of the things in our house, the vacuum cleaner, if you have one of those ones that runs around the house automatically, it has a camera in it so it doesn't bump into things. Not all of them do, but some of them do. All these things are hackable. All of these things are things you do not want someone to get control of. All of these things are now beginning to offer features. You don't just want to give me something to control my heating system. Now you want to give me a feature. You want me to select a particular brand because they're updating features or adding features over time. And those updates and features are highly beneficial to me as the consumer, to you as the consumer, but they're also an attack point for hacking that needs to be secured with the highest level of security and the most trusted keys. The good part about going with quantum enhanced security is that the service provider and the end customer don't need to do anything. There's a simple thing that you need to do when you build your Internet of Things device in order to implement it. There's an additional thing that some people are doing. You can invest in an application that maybe runs on someone's phone or laptop that provides an additional service that you might choose to charge a monthly revenue for. And there are some examples, even in the cell phone space, some of the early usages as an example of a bank who made a particular banking app that only works with quantum phones to offer quantum enhanced security on certain kinds of transactions. And you can charge a monthly service fee for that and generate extra revenue. And there's of course countless ways to do the same kind of thing with every Internet of Things sensor or device out there in the world. So to kind of summarize the value part of this presentation, there's three sort of areas where people are deriving value by implementing a quantum random number generator, one of our Quantis family of random number generators. And the first is that quantum technology itself is a marketing term. The consumer has long shown that if offered a leading edge technology versus a trailing edge technology, they will often buy the leading edge technology, even if they don't specifically understand what the benefits are. So quantum technology in and of itself has already generated higher margins for some of ID Quantique's customers. But in addition, the quantum random number generator does, of course, fundamentally make Internet of Things security more secure. And as we had talked about earlier, 92% of companies who do any kind of security upgrade immediately see an increase in sales, and which is just a phenomenal number. And it just shows how worried people are about security and about the endless news streams of things getting hacked. And finally, there is the ability for incremental revenue and even transactional revenue as you do things like create specific apps to run on your quantum enhanced product, on your quantum enhanced Internet of Things device. And that is a growing part of the market, very interesting and growing part of the market going forward. So I want to take a moment and remind all of you that there is an area on your screen there with the tool here for the webinar where you can enter questions. And as soon as we go through the area where we show you how the quantum is actually implemented in your device and why it helps you, then we're going to answer any of the questions that you ask. So now we're going to go into what is the quantum in QRNG. And for this, I'm going to turn it over to Bruno Huttner, who was introduced to you earlier. And
Bruno, you're on mute. So you have to start again.
Bruno. All right, I think we had some technical difficulties, so I will do this part myself. So the first thing is all data files and all transmissions are encrypted. When they're encrypted, it's done by an encryption algorithm, which is largely a mathematical lock. Just like my front door that I talked about earlier has a lock on it. Same idea here, only it's in the digital world. It's using an encryption algorithm to mathematically lock up that data file or mathematically encrypt that transmission line. And just like the lock on my front door used to have, there used to be a physical key that you would use to open that lock. Now there is an electronic version to open that lock. And it's the same thing in the digital space. We have a file, a data file or transmission line that's been encrypted. And what we want is we want to cure a key that's very secure. That's the attack point for the hacker. The hacker is trying to pick the lock, for lack of a better way to put it, by digitally taking over and simulating your key. And that's where you need to make the best keys. And the foundation for that is random numbers. The key is made, the key has to be made in an unpredictable way in order to prevent the hacker from being able to pick your lock. And so using a true random number generator is the foundation to making the strongest possible keys. And that's the foundation to having good, secure crypto system. And so quantum randomness makes for the best keys. And what do I mean by that? Well, first of all, quantum physics describes a microscopic world. And long ago, quantum physics, one of the many outputs of quantum physics was to prove that light itself, there are certain quantum physics properties about light itself that are intrinsically random. For decades now, people have been doing cryptography using older style random number generators. And even more recently, what we would call classic random number generators, they're based off of electromagnetic noise in the environment, or sometimes they're tapping into thermoelectric noise in the environment. If you are measuring, instead of single digit, if you're measuring in thousandths of a temperature degree, it looks jittery. Or they're measuring even electromagnetic noise in the system. And the problem with that is it's not really fully random, because the human race is injecting periodic signals into that. The fan on your computer, the fan on your refrigerator, the motor in your car, the light bulb plugged into the wall is running off of either 50 or 60 hertz, depending upon where you are in the world. The vibrations, thermal changes, all controlled by air conditioning equipment. The world is injected with lots of periodic signals. So in creating a random number the way people have been doing it for a long time, it's kind of a little bit dangerous because it's not completely random, whereas light is intrinsically random. And we get into how we implement it in our device. So we have multiple light sources actually. In our device there, you see the picture of it. Inside there, there's multiple semiconductor, so they're tiny little light sources. There's multiple sensors, all semiconductors, so everything's tiny. The light itself is generated and travels a very tiny distance before it hits the sensors. Of course, all the filtering and everything is built in. What I mean by filtering, mostly what we're filtering out is the very environmental signals that our competition is using in the classical TRNG to create their random numbers. We want to give you quantum entropy, which is coming just from the light and not the other signals that might have some periodicity accidentally injected into them. Now that's the fundamental thing that we're putting out, the quantum entropy. We have a family of products, and some of them have the option to increase the hash space, increase the post-processing with hash-based DRBG, which gives you a lot of great stuff in terms of auto-calibration and self-test and health test and all that kind of stuff, but does not actually, it's not actually needed for every application. That's why we make the chips both ways, ones with just quantum entropy output and ones that have the post-processed DRBG output. So how do you use it in your system? Well, every Internet of Things device actually looks a lot like a mobile phone in this sense, which is that they all have a processor or a system on a chip. That's the fundamental core of that device. It's actually pretty much looks similar for mobile phones and automotive too, as it turns out in some cases. And those systems on the chips have built into them a CPU processor, memory, general purpose IO, an encryption engine, and a random number generator, what I would call a classic random number generator or the old-fashioned random number generators. And those random number generators, the way that works is you have a file and you want to encrypt it. You need to have it secure. It's a medical record. And the CPU then takes that file and it goes to the encryption engine and it says, encrypt this file. And that encryption engine grabs a random number off the classic random number generator and it makes a key and it encrypts the file. And that's what's been going on for many years. How do you use ID Quantique? Our chip gets soldered onto the board right next to the existing processor or system on a chip that you're using today. It connects in through either the I2C or the SPI bus, depending upon which processor you have. And the same process, you have a file, you want it to be encrypted. The CPU hands it to the encryption engine. And now the encryption engine grabs a random number from the QRNG, from our chip. So it makes the highest level of trusted key in it for that new lock that you've put, mathematical lock that you've encrypted that data file with. And the quantum technology just takes care of the rest. And I should point out on bullet 3 here that the quantum RNG does replace the embedded RNG in this example. There are cases in the mobile and Internet of Things space where people actually blend them together. They don't stop using the classical RNG just due to the way they have their software written. Sometimes that's difficult. So it's easier for them to just take our number and blend it with the other number. And if you do that, it doesn't matter because the quantum random number generator is a pure random number. So it just, in the end, you don't really get an increase of randomness per se, but you're still getting the full benefit of the quantum random number if you do that. So the software stack, very simple. This is all within the shell of the root of trust that you've set up on your Internet of Things device. And at the BIOS level, the chip itself's core software is just having a small amount of code, which we give you, that is, instead of taking the random number from the classic RNG, it's taking it from our QRNG chip. And everything else derives the same way. The applications that you're running, whatever you're running, it runs the same way. This is all under the hood of the engine, if you will. Some Internet of Things device these days are using Android, so I just wanted to show you that the implementation is pretty much identical in an Android style software thing, if that's what you have on your system on a chip. At the end of the day, we're still working with our chip driver at a fundamental low level of software within your processor. So we have multiple devices in our families. We have other quantum random number generators, even these three, but the IDQ 250C2 is our sweet spot today for Internet of Things devices. We have these other devices with varying quantum data rates. All these devices fundamentally work the same. The differences are some of them put out a lot more quantum data rate, which means you can make a lot more keys. Not usually needed for the Internet of Things device, a single device, but some of these devices are used like if you're in a data center where you are managing thousands of channels simultaneously. Other than that, the best part is this is all available today. You can use it now. It's already being used now and already in people's pockets around the world, including mine. And it's a clear differentiator. It brings quantum enhanced security brings a higher level of trust to the security you're implementing, and 92% of the companies in the world have shown that generates more sales. So that's a snapshot of our team there in Switzerland, and we've been focused for years there in Switzerland, 19 years now, and making sure that when we bring a quantum technology product to you, we do so in a way that is not only high quality and best in class performance, but it's operationally simple for you to use, for you to implement and to use, which I hope I've shown you today. So with that in mind, we're going to turn it over to Axel to go through some questions.
Thank you, Tom. Thank you, Bruno. I hope, Bruno, you are now live again. I hope the technology is fixed.
So I don't know. I'm here. Can you hear me?
Now we can hear you and see you. Yes.
Very strange. Okay, I did the same thing. We didn't have a quantum random number generator in my camera, and maybe I was hacked at the wrong moment. Who knows?
Yeah.
But anyway, I'm here now, and if there are questions, I can help Tom to answer. But he did a great job taking from me at the right time. Thank you, Tom.
Okay.
Yeah, thank you. So we received a couple of questions. So maybe I would start with the first question. And the first question is quite operational. I think you mentioned this already a little bit. So how long does it take to implement a QRNG, and how hard is it, Tom? What is the guide? What's our experience? Because we have done this already multiple times with different clients.
Yeah, very much so. So from the hardware point of view, it's extremely simple. There's not a lot of pins on the device. We purposely made it so that for security reasons, we purposely made it so that there's very little you can do with the device. You turn it on and it works. And so from a hardware point of view, it's a very simple, low cost. There's nothing special you need to do with your printed circuit board. Nothing special you need to do with heat sinks or anything. It's extremely low power. From a software point of view, depending upon your application, I've had customers say it's anywhere from 4 lines of code changed to about 30 lines of code changed at a fundamental low level within their processor code in order to use the quantum random number generator instead of the classic random number generator. Very simple. You'll spend far more time doing your regular regression testing afterwards and making sure you find any bugs than you will actually implementing the technology.
Thank you, Tom. And I want to add, we have also a test kit you can buy to make this quite simple upfront. So some of our customers use this test kit already also for products. So that's quite good. So it's easy, and we help you for sure also to implement. Thank you, Tom. The next question is in the direction of Bruno now, as he has his voice back. So we want to use him as well. So how does quantum computer and PQC affect security? And maybe also a little bit a link to QRNG chip. So maybe that's the question on this side.
Okay, so there is no direct link today with the quantum computer. Any kind of cryptography is based on keys, which in turn request random numbers. So whatever you do, is it classical cryptography, it's post-quantum cryptography, or even QKD actually, because in QKD you also generate keys, you do need the random number generator to generate the keys. And having a quantum random number generator allows you not to worry about anything. It means that your generator will not change. I mean, there will be no attack on the quantum random number generator through a quantum computer. The basic process at the heart of the quantum random number generator is quantum. And there is nothing you can do to try and find out what this will come out, what kind of numbers will come out. So let's say the progress in quantum computing and the progress in QRNG go separate. And of course, you will need QRNGs, whatever the progress in quantum computing is.
Okay, good. Thank you very much. Maybe you want to continue also to build this link QRNG PQC a little bit, because I think it's always a topic on this side, which.
Okay, what maybe I should add, thank you, Axel, is to say that actually post-quantum cryptography is using more random numbers than classical cryptography or modern cryptography, as you can call it, because you need to select many parameters in your PQC system, and many of these parameters have to start with a random number. So I would say that PQC is very hungry for random numbers, and therefore putting PQC with quantum random number generator is a very interesting idea. And in fact, we're already working with a company who is doing exactly that for phones. They are using post-quantum algorithm to make the algorithms themselves resistant to the quantum computer. And we add also the QRNG layer in order to make this even more secure. So this is really something, I think the two can really go hand in hand to even provide better security in the quantum era.
Okay, makes a lot of sense. Thank you. Maybe add on from my side. I think we are talking about IoT. IoT, there are a lot of devices. Some of them have processing power, some of them don't. So we always have to consider, if we want to be quantum safe by PQC to IoT, then for sure processing power will be the #1 limitation on this side. So we have to be very smart and clever on the algorithm. There's also
if
a question.
I may, in this case, it's even better to use the QRNG, because the QRNG doesn't really need processing. If you were to try and do a standard random number generator, of course you would need processing power to make it. Here it's built in the chip, so you don't need extra processing power to have good randomness. And if you are really starved for processing power, I think using the QRNG is probably a better bet in this case.
Okay, then there's the final question. I will try to answer, so you can correct me all the time, as always. It's about, if you say we started the quantum decade, what are the proof points? And you have seen the phones, but in the end, it's about numbers. So as the global leader, obviously in the QRNG space, we are right now in the 7-digit space of shipments. So that's something which is quite volume, as you can imagine. And we see that this will increase in the next year dramatically. So we see a hockey stick on the demand side, as QRNG looks like is the new standard for randomness for all manufacturers who want to say, okay, we really take serious the security part, right? So that's, I would say, as the headline and closing on my side. I want now hand over to Catherine to open the polls. I think we have 2 polls, if I'm right. Catherine, you want to start a poll? So it's an interesting question. So do you see projects in the next 6-12 months, or maybe not, on the encryption side? So please provide your feedback on this side. It's always interesting to know what's on the spot from our customers and our audience in general. Catherine, you give me
yes,
the information as soon as you. Yeah.
We are at 50% votes at the moment. I'll wait a few seconds. So the trend is that is positive. Yes, in the coming 6 months, we are reaching 38%. Then 30% yes in the coming 12 months, and some do not know yet. So moving positively.
So quite a substantial number. Thank you for the feedback. Can we open the final poll, which is, I think, feedback to us?
Yes.
Now you change it. Exactly. So it's a very simple question, yes or no. I hope we're always looking for feedback, what topics are interesting, what we can do better or include in our sessions. But in general, also, is this something which brings value to you? Because that's the purpose of the session. So Catherine, you give me the feedback.
Thank you. Yes, we have 60% voters and we're reaching 92% yes.
Okay,
satisfactory.
Good. So then thank you for this feedback. I think the other 8% we have to convince. That's our mission going forward, obviously. I want to close the session saying thank you for your interest to the audience. Thank you to the speakers and Catherine for setting this up and handling this in the background. My name was Axel Furry. I'm heading up the quantum safe business because that's what I missed in the beginning. So enjoy the day, stay safe and secure, and see you soon on this channel. Okay, take care.
Bye-bye.
See you, everybody. Thank you.
Thank you. Bye.